We attempted to solve this problem 1390 in class, and there were some issues with what this z equals negative 2 meters per second. Should have probably, considering the unit, should have been z dot. And then my interpretation was that the tangential to the path speed is 2 meters per second, and if the down speed is negative 2 meters per second, then that corresponds to free falling. So this problem doesn't make full sense. And I pulled out the solution manual, and we recognize the radius being constant, but then he makes use in the solution, whoever prepared it, of an angle that's 11.98 degrees, and this is not explained in any way where it's coming from. I see it as the angle here in this little free body diagram is the angle between the vertical and the normal. It says NB, whatever that direction is. Anyway, so the more realistic problem that I want to solve is this one, where, and it's related with a pilot. Give a mass of the pilot, 80 kilograms, flying on a spiral, vertical spiral of 300 meter radius, and onboard instruments record 5 meter per second descending speed and air speed, that is the actual velocity of the airplane, 40 meters per second. So calculate total force that pilot exerts upon his seat. So what do we need to find? Same as this problem, the reaction forces over the radial, transverse, and z-axis, and since they're orthogonal, you just add them, add their square, take the square root, and gives you the resultant reaction force. Okay, so we have, say, this, or where? Let's assume a point like here, and I'm drawing the radius, so not coincident with one of the drawing of the plane. So we have the radius, and this the radial unit vector UR, and then we have in the horizontal plane, there's the UR, rather U theta. So this is U theta direction, unit direction, and then tangent to the path, it's the air speed, the velocity of the airplane. Okay, so this is velocity V, and this one we know it's 40 meters per second. Okay. And we started looking in class at the helix angle. So we can, from the information given, we can calculate the helix angle. And radius 300 meters, and it's constant. If the down velocity is, so z dot is going to be the velocity of the airplane times sine of the helix angle. Okay, we'll assume this to be, again, an ideal perfect helix, not that a plane could fly easily along a helical path that is mathematically perfect. Okay, so from here we can calculate the angle phi, and this is going to be arc sine of z dot over v equals arc sine. Z dot is 5 over 40, and the value is, so I have 5 over 40 equals arc sine, so it's 7.1 181 degrees. Okay. So we can now state Newton's second law using cylindrical coordinates. So we have sum of forces in the radial direction is mass times radial acceleration. Sum of forces in the transverse direction, mass times acceleration in the transverse direction, and sum of forces in the z direction, it's mass times acceleration in the z direction. Okay. Using the known equations we have in the back of the book, or by the front cover. So the radial acceleration is r double dot minus r times theta dot squared mass times r times theta double dot plus 2r dot theta dot, and then this is mass times z double dot. Okay. I don't know what I'm opening again here. We don't need it. So let's see. Clearly, r dot and r double dot are 0 because the helix is defined as one with constant cylindrical helix. So this equals 0 as well as this one equals 0. So it equals negative mass times radius times theta dot squared. This one is mass times radius times theta double dot, and z double dot is so this is 0 because z double dot is z dot is constant. Okay. Or the assumed constant. So let's say both constant. Okay. All right. So the left-hand side here is clear is going to be the reaction force from the seat R, and this is equal to mass times R times, and we'll need to find theta dot theta double dot at some point, force in the theta direction. It's by itself, reaction from the seat, m times r times theta double dot, and here we have negative weight mass times accelerated gravity, and then I have plus force from the seat in the z direction equals 0. So we found one of the components. This force in the z direction is 80 times 9.1 81. So it's 784.8 newtons. Okay. So let's see. Let's see how we can find theta dot theta double dot. Well, we'll need to look at the formula for velocity. So velocity in the transverse direction is r times theta dot, and there's no velocity in the radial direction, so we have so again, velocity in the transverse direction is r times theta dot. Okay. From here we can calculate theta dot because we know the velocity in the transverse direction. Velocity in the transverse direction is, so this part is going to be the horizontal projection of the velocity that's given 40 meters per second. So we found the angle, and we can state that so again we plug it here. Velocity in the theta transverse direction is velocity times cosine of helix angle. Okay, so that's 40 times cosine of 7.181, and so 7.181 degrees cosine equals, and times 40 equals 39.686 meters per second. Okay, so back to the original equation, we can get theta dot as velocity v theta over r. So I have v theta, I divided by r, 300, and this is 0.1323 radians per second. Okay, so this is enough to calculate the reaction from the seat in the radial and in the transverse direction. Let's see, the theta double dot now, or square. So let me finish this. Okay, so negative mass, that's 80 times 300 times 0.1323 squared. So I have it, I square it, times 300 times 80. This is negative 419.99, easily 420 newtons. Okay, so I have the second one. The third one now, for the third one, we need to decide whether it's 0 or otherwise. So we could or where's the theta double dot occurring? Theta double dot occurs in the expression for radial acceleration. Okay, it's like right here, and that would correspond to the plane accelerating down the spiral. So conclusion is that there's no that this is also 0. Okay, because of the, well, I could have just said that since the velocity in the transverse direction is constant, I have a constant angle, and I have the original velocity being constant. This is also 0. So why is that? Because again, theta double dot equals 0. So we can provide a final answer. F resultant, reaction from the seat, is going to be square root of 420 squared plus 784.8 squared. So this squared plus 784.8 squared equals square root. So it's 890 newtons. Okay. Now if I divide this by 9.81, I get 90.7. So the apparent weight of the, or apparent mass, okay, this is the apparent weight, but the apparent mass is like the pilot having 90.7 kilograms. Okay, so this is the answer.